Question 17 says, a student set up the circuit shown to determine the EMF and internal resistance R of a cell. I is the current in the circuit and R is the resistance of the variable resistor. Show that for this circuit, R equals EMF by I minus R. Forget what the question asks you to show. Just look at the circuit. This internal resistance and the load resistance are connected in series, right? So this EMF will be shared among these two. So this EMF will be equal to IR plus IR. Since they're connected in series, the same current flows through both this load resistor and this internal resistor, right? So EMF equals to IR plus IR. So if you just make I common, if you take I common, so that then it becomes IR plus R. And then you send I to the other side and make R the subject, and this is what you get. Part B says, student varied R and measured the corresponding values of I. The student then plotted a graph of R against 1 by I. All right. So if you look from here, R equals EMF by I, and actually, I have to refer to this actually. So R equals EMF by I minus R. So R equals EMF times 1 by I minus R. And this is in the form Y equals mx plus c. If I'm plotting a graph of R against 1 by I, so the gradient of the graph, since it's in the form Y equals to mx plus c, the gradient of the graph will give the EMF and the y-intercept will give the internal resistance. So from here, the question has to find out the EMF and R for the cell. So like I said, first you have to find out the gradient of the graph and then the y-intercept. As you can see, the y-intercept is -2. And if you take the gradient, it will be this value. So the internal resistance is 2. Of course, resistance cannot be negative. So internal resistance is given by the y-intercept. And if you take the gradient of the graph, the value should be 1.5, gradient of the graph. And please make sure while you're taking the gradient, you always use a large triangle. So I can show you how to take the gradient. So I can take these values. I can take the entire graph. So this is my change in y-axis. So change in y-axis would be 10 minus -2. 10 minus -2, change in y-axis, divided by change in x-axis would be 8, right? So 10 minus -2 gets you 12, divided by 8. 12 by 8 is 1.5. And since it's the EMF, the unit should be volt. Next part of the question says, the student suggested that the power dissipated by the internal resistance R decreases as R increases. All right? Comment on the student's suggestion. Always remember, these two are connected in series. So if R increases, so if R increases, the current in the entire circuit decreases. And according to P equals I square R, the current through the internal resistance also decreases, right? So if I decreases, R remaining the same, the power dissipation decreases. So the student is correct. Next part of the question says, the student added a second identical cell in series with the first cell and repeated the experiment. Add a line to the graph to show the results of the experiment. So when you add a second identical cell, what happens? in series, right? So the EMFs add up. So now the EMF will be twice as before. And since the whole thing is still in series, the internal resistances also add up. So the internal resistance will also be doubled. So when you add another cell in series, both of these values will be doubled. So EMF is doubled and internal resistance also doubles. And EMF was given by the gradient of the graph. So what does it look like when the gradient is doubled? The graph becomes more steep. So this is what the graph should look like. EMF is doubled, as in the gradient is doubled, and previously the internal resistance was 2. Now the internal resistance has been doubled, so that makes it 4.